Okay, you're going to be learning about the box plot today. You learned about it last year. It's also called a box and whisker plot because it has a box, and then out to the side they call these whiskers. What this box plot does for us is it takes 100% of the data, just like a pie chart is 100% of the data. This box plot's 100% of the data, and it divides it up into 25%. So this is 25% from here to here. And this is 25% from here to here. Okay, even though they're different links, they represent 25% of the data. Inside the box, this is 25%. And this is 25%. Okay, so between each point is 25% of the data, even though they're different links. And then you also know that the box is 50% of the data because each of these sections is 25% and 2 25s is going to give you 50%. So this is a way you can look at the percentage of the data. There's 5 numbers you need to make a box plot. You need the minimum number. That's the first dot. You need the median number. That's your middle of your data. You need the maximum. That's your highest number. In between the minimum and the median is the first quartile. So it's a quartile, just like a quarter, like we have 25% of the data, quarter. Okay, so the first quartile of the data is the median of the lower half of the data. So between the median and the minimum, we do another median, and it's called the first quartile. And then the upper half of the data, between the median and the maximum, we do another median, and it's the third quartile. All right, so this is how we divide it up into the 25% with these numbers. All right, so we have the range, which is our high minus our low. And then when we look at a box plot, we have a different range. It's called the interquartile range, and we abbreviate it IQR, interquartile range. And it's when we subtract the third quartile and the first quartile. And this is that 50% of the data in the middle. This is where your box ranges from. All right, so the first example here, we're going to create our box plot. So I have a number line, I have the numbers that we need, and I have the data. All right, so the minimum number is our smallest number, which is 5, and our maximum number is 22. All right, then we find the median. So to find the median, we knock off the high and the low, and 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 the high and the low, till we get to these two 15s in the middle. So since they're both 15, when I average it together, I'm going to have a median of 15. Okay, I rewrote the data over here because we have to find the median of the lower half and the median of the upper half. So since these two numbers are my median, I divide the data in half right there where they are. And this is my lower half. So I want to find the median of my lower half. So I mark off my high and low, and I wind up with an 8 and a 10 in the middle. That's my new median. And 8 plus 10 is 18, divided by 2 is 9. So my first quartile is going to be 9, because that's the median of the lower half of the data. Then I need my third quartile, which is the median of my upper half of the data. So I take these points and mark off a high and a low, and then I get 19 and 20. And when I average 19 and 20, I get 19 and a half. Okay, these are the 5 numbers that I use to make my box plot. So at 5, we want to put a point. Well, this is counting by 2s. So 5 is halfway between 4 and 6. So I'm going to have a dot there. I'm going to have a dot at 9, which is going to be halfway between 8 and 10. I'm going to have a dot at 15, which is going to be halfway between 14 and 16. I'm going to have a dot at 19 and a half, which is going to be fairly close to 20. and I'm going to have a dot at 22. Okay, that's the 5 dots I used to make my box plot. Okay, so the minimum and the first quartile connect, and the maximum and the third quartile connect. And then I make a box. Not the best box, but making a box. All right, and then I draw a line on my median. So this is 25% of the data, 25% of the data, 25% of the data, 25% of the data. All right, the next thing I'm going to do is just calculate the interquartile range, and that's just where I'm going to subtract these two numbers. Okay, so the 19.5 of the third quartile and the 9, I'm just going to subtract those, and I have an interquartile range of 10.5. That's another way of looking at the spread of the data, another range. You have the range that goes from the maximum and minimum, and then you have this interquartile range, which goes from your first and third quartile. All right, our second example here, we're going to take our minimum value of 10, our maximum value of 26. We're going to find the median. So I'm going to mark off a high and a low, and mark off a high and a low, and mark off a high and a low, and then I wind up with a median of 14. Okay, so this was my middle number, this 14. So that divides my data in half right there. So I'm not going to use this 14 when I find the median of the first quartile. So my lower half of the data, I mark off a high and a low, and I wind up with 12 and 13. And 12 and 13 average together to be 12.5. And then I find the median of my upper data. So I mark off the 14 and the 26, and I have 17 and 22 that I need to average together. So 17 and 22 adds up to be 39, and 39 divided by 2 is going to give me 19.5. So my upper quartile is going to be 19.5. All right, I put these dots on my number line. So I have a minimum of 10. First quartile is 12.5. So this is 13 in between there. So this is going to be somewhere about there. And then I have a median of 14, and this is going to be starting my box. I have a third quartile of 19.5, so that's going to be fairly close to the 20. And then a maximum of 26. Okay, so I've divided the data up into 25%. So 25% of the data is between this 12 and 12.5. 50% of the data is between this 12.5 and 19.5. And 25% of the data is between 19.5 and the 26.5. And another thing I can do to look at this data is I can get my interquartile range. So I would subtract 19.5 minus the 12.5, which would give me 7. So my interquartile range, that's a difference of 7. All right, in 7th grade, what you need to do with the box plots is you need to compare two of them. Okay, so this example here, the box plots show the distribution of the number of DVDs sold weekly by two different stores. So we have store A and we have store B, and we're going to collect our data from the different stores. So store A is right here, about halfway between the 0 and the 100. So we are counting by 50s. So we have a minimum of 50 for store A and a maximum of 500. Our median is that dot in the middle of the box, and that's at 200. My first quartile is where the box is, right here, and that is at 150. My third quartile is right here, and that is at 300. Okay, and then my interquartile range is just to subtract the 300 and the 150. So the 300 minus 150 gives me an interquartile range of 150. Okay, store B has a minimum value of 100, has a maximum value of 450 because we're between the 400 and the 500, has a middle value, median value of 350, and its interquartile, first quartile is somewhere between the 200 and the 250, so that's about 225. And its third quartile is right there at the 400. And its interquartile range is going to be the 400 minus the 225. So when I subtract that, I get 175. Okay, so we can see the minimums of both stores, the maximum of both stores, the medians of both stores. All right, so let's answer our questions. The first question is, which store had the greater median? So the one with the bigger median is going to be store B. It has a median of 350 versus 200 on the other one. How much larger is it? Well, let's subtract. 350 minus 200, it's 150 larger. Which store has the greatest spread, the greatest range? Okay, well, you would look from your maximum and your minimum. So from 50 to 500 is 450, or from 100 to 450 is 350. So store A is spread out more. And D, what's the minimum of store B? Store B, the minimum is 100. So what you're going to do is you're just going to look at two different box plots, get the information from it, answer some questions about it, and compare them.